With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
The given question is, in the arrangement shown below, pulleys are massless and frictionless and threads are inextensible. Blocks of mass m1 will remain at rest if, and these are the given options we have. So now we are given an arrangement of two pulleys A and B on which three masses are hanging, okay, m1, m2 and m3, and we are given the condition that mass m1 should remain at rest. Okay, so let me draw the free body diagrams first. So we have, let this be the mass m1. Okay, on mass m1 there will be a weight acting in the downward direction, which is m1g, and there will be a tension, let's say T, acting in this thread. Okay, this is tension T in the thread. So this is the free body diagram of the block of mass m1. Now as the threads are given massless and frictionless, so same tension would be acting in this side of the thread also, right? The tension will be same at every point on this thread. Okay, now see, this pulley B will also remain at rest. Why? Because see, pulley B is directly connected to the mass m1. So if pulley B is moving, that means the mass m1 is also moving. So now for the B, and let's say in these threads tension T1, and here also tension T1 is acting. Okay, so now we have to find the relation between T and T1. Now see, we are given that mass m1 must remain at rest. So for that, pulley B must also remain at rest. Why? Because see, pulley B is directly connected to the mass m1. So if pulley B is moving, that means mass m1 is also moving. So pulley B must remain at rest, and for that condition the tension T must be equals to T1 plus T1. Okay, the net forces acting on the pulley must also remain in equilibrium. So we will get from here T equals to 2 times of T1. Let this be equation 1. Now let me draw the free body diagram of mass m2 and mass m3. So we will get here, this is m2 and let's say this is m3. So we are not given an information about masses m2 and m3. So I am taking m3 to be greater than m2. Okay, so for that m3 will be having an acceleration in the downward direction, and similarly m2 will be having an acceleration in the upward direction. Okay, so and there will be weight of m2 mass acting in downward direction and t1 acting in upward direction, and it is moving up with an acceleration of a. Similarly, t1 tension acting on the mass m3 and weight acting in the downward direction, that is m3g, and acceleration acting in the downward direction. So now this is the complete free body diagrams of the three masses. Now we have for mass m2, this is mass m2 and this is mass m3 block. So for mass m2, if I write the equilibrium force condition, we will get T1 minus m2g must be equals to m2a. Okay, and from here we will get T1 equals to m2, we can take common, and we will get g plus a. Let this be equation 2. Now in this equation the acceleration a is unknown, so the value of acceleration can be found by the equations given from the mass m3. So for mass m3, if I write the force equations, we will get m3g minus t1 equals to m3a, right? So from here we can put the value of t1 from equation 2. So we will get m3g minus m2g minus m2a equals to m3a. Okay, so from here finally we will get the value of acceleration after solving this equation as g times m3 minus m2 whole divided by m3 plus m2. Okay, now putting this value of acceleration in equation 2 here, so we will get here t1 must be equals to m2 times, we have here g plus g times m3 minus m2, this is m2 here, m3 minus m2 divided by m3 plus m2. Okay, so we can take g common and we can take the LCM here, so we will get m3 plus m2 plus m3 minus m2 whole divided by m3 plus m2. From here the m2 term will be cancelled out, and the finally t1 will be given as 2 m2 m3 g over m2 plus m3. Okay, now from this equation 1 we have the tension T in the string given as 2 times of T1. So T equals to 2 times of T1. So that is 4 m2 m3 g whole divided by m1 or m2 plus m3. Okay, now from the free body diagram of block of mass m1 we can write T must be equals to m1g. Okay, so T must be equals to m1g for mass m1 to remain at rest. So from here, putting the value of tension T, we will get 4 m2 m3 g whole divided by m2 plus m3 equals to m1g. From here we can cancel out the term g, and we can take 4 in the denominator here. Okay, let me rub it from here, and g also we can remove. Okay, so this will be the equation we are getting. So and now we can reciprocal both the sides, so we will get m2 plus m3 whole divided by m2 plus m3, and this must be equals to 4 divided by m1. So this equation we can write finally as 4 by m1 equals to 1 by m2 plus 1 by m3, and this is the required relation between three masses. And from the given options we have option A, B, C and D. Option C will be the correct answer. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.